Hello students, this is part 1 of a 3-part video tutorial on different methods of preparation of salts. In this part I'm going to talk about the precipitation method to make salts and how to predict the reactants that should be used in order to make a salt by precipitation method. Now, before I explain the precipitation method, it's quite useful to understand what kind of salts are soluble in water and what kind of salts are not. You're not expected to memorize all these rules, but the first two rules in particular are quite useful because they will help you in predicting the reactants that need to be used in order to make a salt by precipitation method. So let's just have a look at these two rules. The first rule says that all salts of sodium, potassium and ammonium are soluble. So that means no matter what kind of sodium salt you have, whether it is sodium chloride, whether it is sodium sulfate or it is sodium phosphate, all of these salts are going to be soluble in water. Remember that most of the reactions between ionic compounds happen in aqueous solution because the aqueous solution allows the ions to be dissociated. So if your salt is not soluble in water, that means the ions won't get separated, and without the ions getting separated, the reaction between compounds usually doesn't happen. The second rule of solubility is that all nitrates are soluble in water. So whether it is calcium nitrate, so whether it is aluminum nitrate, so no matter what kind of positive ion there is, all nitrates are soluble in water. The other rules are useful to remember. The first two rules in particular are very useful in predicting the compounds that should be used to make a salt by precipitation method, as you will understand in subsequent slides. Now, in your previous lesson, you prepared a salt by precipitation method. That was a different salt, barium carbonate. The image shown here is making a different salt by precipitation method, which is lead iodide. That was demonstrated to you in an earlier class. The visual here gives you the stages that are involved in order to make a salt by precipitation method. The most important thing to keep in mind is that this method is only suitable for making insoluble salt. So if your salt is not soluble in water, then the only option you have is this method. If your salt is soluble in water, then you need to choose another method. So how do we proceed with the precipitation method? The first thing you do is that you choose your two soluble salts, and I'm going to shortly discuss how do you choose those two salts, and you dissolve them in water to make their aqueous solutions, right? And as I explained before, you need to make aqueous solutions to ensure that the ions get separated, and only when the ions get separated is a reaction possible, right? Once you have made those two aqueous solutions, as you can see in this image, these are two different aqueous solutions. You mix them into each other. Now it really doesn't matter if you add one to the other, right? In whichever order, it really doesn't matter much. But you mix them together, and if you have chosen the reactants appropriately, then you should be seeing the formation of an insoluble substance, as you can see the yellow substance here. We call this a precipitate, right? Now because this precipitate is insoluble, you can separate it from the remaining solution by using ordinary filtration, as you did in your previous lesson. Now once you filter, you are only interested in the residue, the insoluble part, right? So you reject the filtrate that's not useful to you, and you allow the residue collected on the filter paper to dry, whether slowly in sunlight or you can place it in an oven. I apologize in advance for this typographical error, but you place it in an oven uh, to remove moisture if you want to obtain your precipitate quickly. Otherwise, you can just put it out in the sunlight. If you ever get a long answer type question on making a salt by precipitation method, then all these details have to be included in that step by step procedure. The only question that remains to be answered here now is, how do you know which salts to choose if you have to make a salt by precipitation method? So let's just explore that. Let's imagine we have to make a random salt X, Y, and I have shown the charges here, which means X has a positive charge and Y has a negative charge, which is the case in every compound. For example, if I'm making something like silver chloride, silver has a positive charge, chloride has a negative charge. So you can relate the X and Y here. Okay. So let's imagine this is the insoluble substance which you have to prepare in a laboratory. So now the immediate question is, what reactants should I mix together in order to get this compound XY as my precipitate? So we look at step number 2. We know that this has a positive ion X, so we need to combine, one of the reactants will have the X positive combined with nitrate ion. So since here, if we assume the valency of X is 1, and we know that the valency of nitrate is also 1, the salt that would be used would be XNO3. So that is going to be your first reactant. Okay. Let's just assume that the valency of X is not 1. Let's say it's 2. So of course, the formula of the salt is going to be different. So this time it's going to be XNO3 whole twice. All right, I'm going to give you a specific example in the next slide. So if certain things are not clear, just wait for that specific exemplar. And if you're still not clear, please reach out to me during lesson to clarify. So this salt, this X nitrate, is going to be the first reactant that you would have to prepare. Okay. The second react In order to get the second reactant, you combine your negative ion, which is Y minus, with either sodium or potassium. Now you might be wondering that why am I specifically pointing out nitrate in the second step, and sodium and potassium on the third step. Is because if you looked at the very first slide, the solubility rules clearly state that all their salts are going to be soluble. And in order to make a salt by precipitation method, you need to mix aqueous solutions of two different compounds, which means you need to make sure that both the reactants that you're choosing are soluble in water. That's the reason why you combined X with nitrate and selected that as your first reactant. And in the same way, we are combining our negative ion Y with either sodium or potassium. So for example, if my potassium has a valency of 1, and let's also assume that Y, the negative ion, also has a valency 1, then the compound that I need to select as my second reactant is KY. Alright, so this is how you choose your reactant. So once you get your reactants, all you have to do is dissolve these two compounds XNO3 and KY in water to make their aqueous solution. So you have two beakers, you dissolve XNO3 in one, so this is XNO3 aqueous, and you dissolve KY in the second one, so this is KY aqueous, right? Now once you mix them with each other in whichever order, whether you pour XNO3 into KY or KY to XNO3, just ensuring that there is no spillover, this is the reaction that's going to happen. So you have XNO3 where X is positively charged and NO3 is negatively charged, reacting with KY where K is positively charged and Y is negatively charged. In this kind of reaction, there is a swapping of positive and negative ions. So what happens is that X leaves NO3 and instead combines with Y, because this works because it has more affinity towards Y. So X combines with Y and forms XY, while K combines with NO3 and makes KNO3. So as you can see, there is an exchange of ions happening between the two compounds. And such a reaction is called a double displacement reaction. Okay, and you can guess why the name is double displacement. That's because the two ionic compounds are mutually exchanging their ions. Now, in the previous slide, you also saw that you generally wash the precipitate with distilled water to get rid of impurities. Now, the question is, what could those impurities be? As you can see, in addition to the precipitate that I wanted, I'm getting another product. And going by the solubility rule, the second product is soluble in water. There is a possibility that the precipitate that you collect in your funnel might be contaminated with this impurity. It might have traces of this potassium nitrate. So in order to get rid of these traces, you repeatedly wash it with distilled water, and this will just clearly get rid of KNO3 because XY is insoluble. So you won't be able to lose it just by merely washing it. All right. Now let's look at a specific example just to clarify these steps. So let's say you want to make silver chloride. Okay, step number one, you write the chemical formula, and when you write the chemical formula, you can easily identify that my positive ion is Ag plus and my negative ion is Cl minus, right? You might recall that silver is a transition metal, and transition metals are known for exhibiting different valencies. But as I have discussed with you before in a previous tutorial, whenever not provided with any information, you assume the charge on silver to be plus 1. And of course, for chlorine, the valency is 1, so the charge on chloride is minus 1, as you can guess from the periodic table. So the two ions that I need in order to make my precipitate are silver ion Ag plus and chloride ion Cl minus. Now I need to make two reagents which can act as source of these two ions. So going with step number 2, we need to combine the positive ion with nitrate. Okay, so we know that the positive ion is silver. So reactant number 1 is going to be obtained if I combine silver ion with nitrate ion, and I get my first reactant. That's going to be silver nitrate. Okay, so it's just like in the previous slide we had a generic example of X. Here X is Ag plus. So the first reactant can be obtained by just combining silver with nitrate ion. Now, how do you get your second reactant which will act as a source of chloride ion? The second, in order to get the second reactant, you need to combine chloride with either sodium or potassium. So in this case I've combined it with potassium. Okay, so when you combine sodium, potassium and chloride ion, the second reactant that you need is potassium chloride. It could also have been sodium chloride because we know both of them are soluble. So the two reactants that I need to mix together to get this precipitate would be silver nitrate, the formula of which is going to be AgNO3, and potassium chloride, which is KCl. Okay, so we again, now that we know that these are the two reactants in order to make my precipitate, I make aqueous solutions of these two compounds in two separate beakers, right? And once I make their aqueous solution, I add a fixed volume of one of these compounds into the other. So let's say I add silver nitrate to to potassium chloride, but I could have also done the other way around. Once you mix these two compounds, you stir the mixture with a glass rod stirrer to ensure that the reaction is complete until no more precipitate forms. Then you filter using a filtration setup, and it's the residue which has your silver chloride. You wash the residue with distilled water so that the impurities of potassium nitrate, which is water soluble, can be removed. And then, just as in the previous slide, you allow the precipitate to dry in sunlight or oven on a filter paper. Okay, so if you ever get a long answer type question to prepare a salt by precipitation method, you need to write the steps in this manner. Of course, nobody is going to ask you how to deduce the reactants in order to get the required product, but you will have to identify those even if you are not showing how you deduce that. So in this tutorial I've explained how precipitation method is used to make insoluble salts, but the most important skill that you need to develop is how to identify the starting reactants which can be used to make a salt by precipitation. Once you have watched this tutorial, I want you to do question number 1 of the review worksheet that has been provided to you. If you have any questions, please let me know during lessons. Thank you.